Dear students, today I am going to teach you the numerical integration. Okay. Actually, what is numerical integration? The process of finding the approximate value of the definite integral, that is integral a to b f of x dx. Definite integral, we have both lower and upper limit, without integrating the function, by using only the values of x and y. Got it? Okay. The first value of x is denoted by x0, next x1, x2, etc., xn. Similarly, the corresponding values of y, that is y0, y1, y2, etc., yn. Here, x0, x1, x2, etc., xn are equally spaced. That means common difference is same. That common difference is denoted by h. Okay? And always we take a lower limit. This lower limit as x0 and upper limit b as last value of x, that is xn. Okay? If we divide b minus a, upper limit minus lower limit, divided by step size of the x values, that is common difference between x values, that gives n. What is n actually? N is number of equal intervals. Okay. For example, I will take a is equal to 1, b is equal to 2. Okay. I will take h is equal to 0.1. Step size is 0.1. Okay. Then we can find n. N is b minus a divided by h. That is 2 minus 1 divided by 0.1. That is equal to 1 by 0.1. That is 10. That means if we divide 2 minus 1 into 10 parts, n equal parts, the step size is always 0.1. Or if we take a step size h is equal to 0.1, we can find 10 equal parts. Okay? 10 equal parts. That means n is equal to b minus a divided by h. That means using h we can find n, or h is equal to b minus a divided by n. Using number of equal intervals we can find h. Okay? By using this concept, we can find the approximate value of the definite integral. Okay? Actually, there are four numerical, there are four rules in the numerical integration. Okay? First rule is trapezoidal rule. Next one is Simpson's 1/3 rule. See, first one is trapezoidal. Next is Simpson's 1/3 rule. Next one is Simpson's 3/8 rule. And last one is the Wedel's rule. But you have only three rules. That is Simpson's 1/3, Simpson's 1/3, Simpson's 3/8, and Wedel's rule. Okay? I will tell you how to write the formula for Simpson's 1/3, 3/8, and Wedel's rule. Okay? For Simpson's 1/3 rule, integral a to b f of x dx is, this is for Simpson's 1/3 rule. 1/3, see 1 by 3, that means you know what is h. H is the step size. Multiply with 1 by 3, that is h by 3. Got it? For Simpson's 1/3 rule, you have to multiply the step size h with 3. Then First value, here we are using only y values, not x values. Only y values. First value is y naught plus last value is yn. First term of the Simpson's 1/3 rule is first value plus last value. Next term. I will write third term. Afterwards, I will come to the middle one. Okay. This rule, Simpson's 1/3 rule, is applicable only for multiple of two intervals. Multiple of two intervals means the interval should be 2 or 4 or 6 or 8, etc. Okay. Just remember 1/3 rule for what? Multiple of 2. Take third term, first one, y2, next y4, next y6, etc. Very important. Simpson's 1/3 rule is applicable for multiple of 2. In the third term, take multiple of 2, 2, 4, 6, etc. Next term, middle one. Write the missing terms. Missing terms are, here we have y naught. Next take y1. We have y2 here. Next y3. Next y5 plus etc. And the last term is in the first one. Now come to the coefficients. 1, 4, 2. Coefficients in the Simpson's 1/3 rule is 1, 4, 2. Okay. Suppose I will write the Simpson's 1/3 rule for just two intervals. Okay, for two intervals. For two intervals, values of y are y0, y1, y2. See, 1, 2, two intervals. For two intervals, how many values are there? 1, 2, 3. 3 values. Okay. In general, suppose if we have n intervals, we have n plus 1 values. Very important. For n equal intervals, we get n plus 1 values. For two intervals, we get 3 values. Okay. For these 3 values, Simpson's 1/3 rule formula is h by 3. Okay. First term is y0 plus last term is y2. That's it. First term is over. Next term. Come to the next one, third term. First term should be start with y2, correct? y2. In the third term, first term is y2. Already we took y2 here. No one need to take any term here. That means 0. Got it? Next, in the middle one, you have to take the missing terms. y0, y2. You have to start with y1. Next one is y3. There is no y3 here. Leave it. Only one term, y1. Now come to the coefficients. 1, 4, 2. 2 into 0. This is for two equal intervals. Simpson's 1/3 rule for two equal intervals. Okay. Next, I will write the formula for Simpson's 3/8 rule. 3/8 rule. Okay. For 3/8 rule, same as previous one. Integral a to b f of x dx is multiply h with 3/8. Got it? For Simpson's 1/3, we multiply step size with 1/3. For 3/8, 3h by, that is 3/8 into h. Next. Now, first term plus last term. y0 plus yn, same as previous one. Next term. See, Simpson's 3/8 rule is applicable only for multiple of 3 intervals. This is for multiple of 2 intervals. Multiple of 3 means 3, 6, 9, 12, etc. Okay. Now I will write the third term. Same as previous one, 1/3 rule. Multiple of 3, y3, y6, y9, etc. Next term. Middle one is missing terms between first and third term. Missing terms. We have y0, y1, plus y2. We have y3 here. Okay, next term. y4 plus y5 plus etc. Next term. We have y6 here. y7 plus y8. Next we have y9 etc. Okay, etc. Now come to the coefficient. Coefficient is 1, 3, 2. Coefficients in the Simpson's 1/3 rule is 1, 4, 2. Here 1, 3, 2. Okay. Now I will write this 3/8 rule for minimum equal intervals. Minimum in this case is 3 only. 3 equal intervals. For 3 equal intervals, the values of y, these values of y are called as ordinates. Okay. y0, y1, y2, y3. See, y0 to y1 one interval, y1 to y2, next y2 to y3. How many values are there? There are 4 values. Now, come to the formula. 3h by 8 into first plus last value. First value is y0, last value is y3. That's it. First term is over. Next term. Come to next one. Actually, Simpson's 3/8 rule for multiple of 3. 3 equal intervals. First term should be start with y3. Already we took y3 here. No need to take y3 here. No y6 term, leave it. 0. Next term. Middle term. Missing terms between first and last terms. Missing terms yadu? We have y0 here. y1, y2. Next y3 is here. The y3 should be either in the third term or first term. Okay, since y3 is the last term, we took in the first term. Next y4, y5. There is no y4 and y5. That's it. And coefficients 1, 3, 2. This is for 3 interval. This one is the general formula. Okay. Next 1/3 rule, general formula, and for the minimum equal intervals, 2 intervals. Okay. And last one is Weddell's rule. Very important. Weddell's rule. Weddell's rule is applicable for multiple of 6 equal intervals. Multiple of 6, very important. Simpson's 1/3 rule is for multiple of 2 intervals. Simpson's 3/8 rule for multiple of 3 interval, and Weddell's rule is for multiple of 6 equal intervals. For 6 equal intervals, what are the values? y0, y1, y2, y3, y4, y5, y6. How many values are there? 1, 2, 3, 4, 5, 6, 7. See, for 6 equal intervals, we get 7 ordinates, 7 values. Very important. This is intervals. This one is ordinates. Okay. Now, using these 6 equal intervals or 7 ordinates, we can evaluate the integral f of x dx by using Weddell's rule. Here also same as previous one. First write h, but here you have to multiply h with 3 by 10. Very important. Simpson's 1/3, 1 by 3. Simpson's 3/8, 3 by 8. Weddell's 3 by 10. Okay. Now write all the terms. y0, y1, y2, y3, y4, y5, y6. Okay, we take open bracket. Now y0, y1, y2, y3, y4, y5, y6 are 7 ordinates for the 6 equal intervals. Coefficients of these 7 terms are very important. See, 1, 5, 1, 6, 1, 5, 1. What are the coefficients? 1, 5, 1, 6, 1, 5, 1. See, 1, 5, 1, 1, 5, 1. Done. We have 6. 1, 5, 1, 6, 1, 5, 1 are the coefficients in the Weddell's rule. That's it. Okay. Next, suppose if we have 12 intervals. 12 means 6 into 2, 12 equal intervals. Okay. For 12 intervals, we have y0, y1, etc. up to y12. Got it? We have y12 values. That means 13 ordinates. y1 to y12. 12 plus this one, y0. 13 ordinates. If you have 13 ordinates, in that case, this is for 12. That is 6 into 2. 12 equal intervals. Formula is 3h by 10. Same as previous one, y0, y1, y2, y3, y4, y5 plus y6. Right up to y6. Next up, plus. Again start with y6. This is y0. First term start with y0, end with y6. Next, since we have 12 equal intervals, start with y6. Next, y7, y8, y9, y10, y11, y12. Okay? Now come to the coefficients. 1, 5, 1, 6, 1, 5, 1. Next up. Same. 1, 5, 1, 6, 1, 5, 1. Got it? This is for 12 equal intervals. Next, suppose if you have 18 intervals, 6 into 3, 18 intervals. In that case, again start with 12, end with y18, write all the terms with the coefficients 1, 5, 1, 6, 1, 5, 1. Got it? These three rules are very important. From these three rules, you will get two questions. Question number 9C and 10C. But in the examination, you are going to write either 9C or 10C. Okay? Suppose if you have 6 equal intervals. For 6 equal intervals, 6 is a multiple of 2 and also multiple of 3. If you have 6 equal intervals, we can apply all the 3 rules. Because 6 is multiple of 2. Simpson's 1/3 rule is for 2 equal intervals. Simpson's 3/8 for multiple of 3. 3, 6, etc. And Weddell's rule is for multiple of 6. That means 6. If you have 6 equal intervals, we can apply all the rules. If you have 8 equal intervals, 8 is the multiple of 2 only. That means we can apply only Simpson's 1/3 rule. Suppose if you have 9 equal intervals, 9 is multiple of 3 only. That means we can apply only 3/8 rule. Got it? And if you have 12 equal intervals, we can apply all the 3 rules. 1/3 because 12 is a multiple of 2. And 3/8 because 12 is a multiple of 3 also. And Weddell's 12 is a multiple of 6. We can apply Weddell's also. Okay? Suppose if we have 7 equal intervals, in that case, 7, not possible to apply these 3 rules. We can apply only trapezoidal rule. But trapezoidal rule is out of syllabus. Okay? Now, I will come to the problems. I will explain one problem in Simpson's 1/3, one problem in Simpson's 3/8, and one problem in Weddell's rule. Because already I have given notes. Okay? Now come to the first example. First problem. Here, evaluate integral 0 to 6 yx. Yx means y is a function of x. Here, directly x and y values are given. This is simple one. No need to worry about this. Okay, come to second one. First one is very simple. Directly x and y values are given. But that is not important. Now come to the second problem. Here, function is given. Evaluate 1 to 2, 1 by x dx in steps of 0.2. By taking step size 0.2. That means h is equal to 0.2. Okay? Here y, that means f of x is 1 by x. H is 0.2. Okay? since h is 0.2, what is our a here? A is 1, b is 2. Now find the number of equal intervals. How do you find the number of equal intervals? N is equal to b minus a divided by h. That is n is 2 minus 1 divided by 0.2. That is equal to, if you divide 2 minus 1 is 1 only, 1 by 0.2. That is, we get 5. 5 means not possible to apply Simpson's 1/3 or Simpson's 3/8 or Weddell's rule. That means we have to solve by using trapezoidal. See here, trapezoidal rule. Leave it. These are all problems related to trapezoidal. Okay, we have problems related to the Simpson's 1/3 rule. Okay, see here. 0 to 3. F of x, 1 by 1 plus x. 1 by 1 plus x. By dividing into the intervals 0 to 3 into 6 equal intervals. A is 0, B is 3. A is 0, B is 3. Dividing into 6 equal intervals means find h. What is that? B minus a divided by 6. That is 3 minus 0 divided by 6, 0.5. H is equal to 0.5. Now, y is 1 by x. 1 by 1 plus x. Okay. First value is 0 only. See, first value is 0, last value is 3. By taking step size 0.5, take 0. 0 plus 0.5 is 0.5. Next, 0.5 plus 0.5, 1. 1 plus 0.5, 1.5. 2, 2.5, etc. For these values of y, for these values of x, find y values. How do you find y values? Substitute x value in the given function 1 by 1 plus x. That is y naught is 1. Use calculator to find the values. Next, if you substitute x is equal to 0.5, you get 0.667. If you substitute 1, you get 0.5, etc. These are all your ordinates for 6 equal intervals. See, 0 to 0.5, 1 interval. Next, this 2, 3, 4, 5, 6 intervals. For 6 intervals, we get how many ordinates? 1, 2, 3, 4, 5, 6, 7. 7 ordinates. For n equal intervals, we get n plus 1 ordinates. Okay. Now, by using y0 to y6, you know how to write the formula. Simpson's 1/3 rule. See, h by 3. First term plus last term. y0 plus y6. Next term. And this rule is applicable only for multiple of 2. Correct? Come to the third one. y2 plus y4. y2, then y4. y6, next one is y6, but we took y6 here, leave it. Right, only these two terms. Next term. Middle one, missing terms. 4, y1, next to 1, 2, here we have 2, 3, we have 4 here, 5. Next is 7, there is no 7 here. No